I'm good. How are you?
Good. All right. Do we want to start with 12 here?
Yeah.
Okay. And our choices are June, or those multiple choices there?
Yeah.
So this is the subscribers since January of 2001.
Uh-huh.
Notice that at that point right there, that's January 2001.
So 0, 0?
Well, just on the x-axis. That's
Okay.
January 2001. If I move one notch to the right, that's 1 month later, I think.
Oh.
I mean, they don't really say that. Oh, no, excuse me, that's 1 year later. In other words, the x-axis is the year since 2001. So that's January 2001, that's January 2002, that's January 2003. So let's back up. When did they first offer it? Well, that would be where the y is 0, right?
Yeah.
So 3 years before January 2001.
Oh.
January
So it'd be
98. We know it can't be back here because when they first, the moment before they first offered high-speed internet, they didn't have anybody. So it has to be 0. And in other words, there's no negative. Back in 1995, they didn't have negative 8,000 customers. They had 0. So there's no point in going to the left of that point, and that point right there is where they had to have started.
okay.
All right.
Well, I looked at the key and it said the answer is March 1998.
Really?
So B.
What are these numbers up here?
They're points.
Okay, I see. Those are data points.
Yeah.
Trying to figure out why that's the case.
Mm-hmm.
And I notice a lot of algebra that you did over here. And
I was just trying to find the equation.
Right. There's nothing wrong with that. If we couldn't read the graph, we could do that. I'm trying to figure out why we can't just read the graph. Why is it not 3 years before January of 2001? Let me think. It says March 1998. Okay, I get why.
Okay.
This graph is not accurate enough to read the exact answer. Notice that that's just 2 months after January.
Okay. Yeah.
I was thinking we could read the answer and also thinking that that line went through that point at -3. Well, it doesn't. I'm looking at it a little closer here and I realize that it actually crosses that axis between -2 and -3. By a couple of, just a fraction was all it would take to be 2 months. In other words, each one of these is 1 year. So it's all I got to be is 1/6 of the way, and that's 2 months. So the reason, the way we get the answer is through the algebra of it. We can't solve it for graphically, because the graph isn't precise enough. So we do have to use algebra. Let me bring up my writing thing here. Hold on. Sorry about that. I didn't notice that the first time I looked up.
No, you're good.
So what we need is the equation of that line, and then we need to set y equal to 0. In other words, if I had the equation of the line, say 2x plus 10, well, I need to figure out where that's at. Well, that's where y equals 0. So I would set that equal to y and solve for x. Okay? So let's figure out what the equation of the line is, and that's where these 2 points are going to come into play. Given 2 points, you can come up with the equation of any line, right? 2 points determine a line. So what do we need to put it into this format?
Slope and y-intercept.
Slope's a good place to start, and y-intercept's another good one. But we're going to need to calculate both of them. Slope is what?
It'd be y2 minus y1 over x2 minus x1.
Given these points, we have 16.1 minus 10.1 divided by 5.3 minus 2.3, which is 6 over 3, so the slope is 2.
Yep, that's what I got.
Okay, plug that into our equation. Now how do we solve for b?
You plug in a point.
Okay, let's take the easiest point to plug in, this one.
Okay.
What do I get?
So it'd be 2 times 2, or 10.1 equals 2 times 2.3.
And that allows us to solve for b.
Yep.
So what is b?
5.5.
Now we have our equation of the line, which is y equals 2x plus 5.5, which is what we want to set. We want to know where y is 0, because when y is 0, that's when they started. Okay, so we solve this equation, substituting 0 for y. And we get x equals minus 2.75.
Okay.
Well, that means we got to go 2 3/4 grids to the left. Well, every 2 is 12 months. 0.75 is 3/4 of a year, so that is 9 months. So I need to go back 33 months from January of 2001.
Okay.
Now, oddly enough, that takes it back to April 1st. Right? Or does it? Yeah, let's see. If I go back 24 months, I'm back to January 1999. Now, let's see. If I go back one more month, I'm at December 98. So I got to go back 8 more months. That does put it at March 90.
Okay.
All right. Sorry about that.
Hey,
we had such a precise graph, I thought we could just read the graph, but I forgot that these are in years, not, and you can't really delineate down to months when you're looking at, you know, 1/8 of an inch equals a year.
Yeah.
All right, let me open up the second page here. That was all that was on that page, is that right?
Yes.
Okay. Which one here? Number 16?
Probably number 17.
Okay.
I mean, this is pretty, like, I just need, like, a review on this, because
Okay.
it's a little, like, I kind of forgot.
Let's talk, what is the nth term for an arithmetic sequence equal to?
A1 plus D
Common difference.
times n minus 1.
Right. Okay, that's where we start all arithmetic sequence problems.
Mm-hmm.
So, write the rule for the nth term of the sequence shown in the graph and find the 50th term.
Okay.
What's the common difference of that?
-3. Or no, it's 4.
Right,
Plus
plus 4. In other words, this is the nth term here. So, the 50th term is the first term, which is what?
8.
Plus the common difference times 50 minus 1.
Oh, okay.
8 plus 4 times 49, whatever that number is. Must be 204?
4 is, yeah, 204.
That's the 50th term. And the rule that they want is this right here.
Okay. Okay, that was pretty easy.
Okay, let me just check 16, make sure you did it right. 16's a little harder. Let's do 16.
Okay.
They're telling me that the 10th term is 25. You know the 10th term is equal to the common difference times n minus 1, right? So 25 is equal to the first term plus the common difference times 9.
Uh-huh.
And the common difference is minus 3. I didn't even look that far. So we can solve for a sub 1.
Okay.
Notice a sub 1 is 52. Now that I have a sub 1, I have the specific formula for this sequence. I go back up to here. A sub n is equal to a sub 1, which is 52, minus 3 times n minus 1. Now, I can simplify that, and you need to. In other words, you don't want to give this as an answer. The nth term is actually now equal to 52 minus 3n plus 3, 55 minus 3n. There's the rule that they want.
Oh, okay.
Okay? In other words, that's what you wrote here. No, not quite.
Well, that was just the first part.
Okay.
I just hadn't gotten any further.
Yeah, once you get the rule, in other words, once you get this first part, then the 30th term becomes relatively easy. You with me?
Mm-hmm. Yeah.
Okay. And it's as straightforward as that. Let's look at 18. First.
Okay.
do you know this sequence is arithmetic?
There's a common difference.
Which is what?
5.
And the first term?
4.
Okay, so what's the rule?
It'd be n is equal to 4 plus 5 and then n minus 1.
And now simplify that.
So 4 plus 5 n minus 5, so it would be an is equal to negative 1 plus 5n.
Right. Now it's easy to figure out any term.
Okay.
Now, is there anything else on this page that regarding arithmetic sequences?
I don't think so. I think that was it.
Okay. Do you have to do sums? I don't see any questions asking for the sum of a sequence. You haven't gotten to that yet?
I don't think so.
Okay. Well, I won't go over that then.
Okay.
It's just another formula you have to memorize. But like if I said, what are the sum of those 4 terms, there's a nice handy formula that you can use.
Okay.
The main thing you want to memorize is this. If you got this memorized, then everything else can be figured from that.
Okay.
You can always simplify your rule. In other words, once you find out what a sub 1 and d is, then contribute the d to the n minus 1 and combine the number with a sub 1, like we did in those examples.
Okay.
Anything else that you'd like to go over?
I have other stuff on another packet.
Okay, can you read it? Is it stuff you can maybe, we got 10 minutes, can you verbalize it?
Yeah.
Okay. I mean, you can take a picture and send it if you like, but if it's something verbalized, it's probably easier to just do that.
Yeah, I can just read it. So it says, a boy 4 feet tall shoots a basketball into the air with an initial upward velocity of 30 feet per second.
Okay.
And then it said, A says, when does the ball reach its highest point?
Okay. Does it matter the angle that he shoots the ball at?
I don't think so.
No, it doesn't. Because the only thing that determines the ball's height is the gravity. In other words, if the 4-foot tall boy shoots it straight up, it comes down. This maximum height is the same whether he shoots it that way, as long as the vertical component of the initial velocity is 30 feet per second. What's the general equation that covers the motion of this projectile, the vertical motion?
Let me see if I can...
Height equals minus 16 t squared plus the initial velocity times plus the initial height.
Okay.
So if I plug everything in, I've got minus 16t squared plus 30 plus 4.
Okay.
That is the height of the ball at any point in time. That is a quadratic.
Okay.
What do we know about quadratics? We know that they always graph as parabolas.
Mm-hmm.
And in fact, they graph like that kind of a parabola, because the negative 16 means it's a parabola that opens down. So if I want to know the height, I have to know where it hits the height, at what time. This is the time axis here. This is the height axis there. So I want the vertex of that parabola. Well, where is the vertex? What's the formula for the x-coordinate of a vertex? Minus b over 2a. Have you learned that?
Yeah.
Okay. So what is b?
30.
So minus 30 over 30 minus 32. So at 15/16 seconds, it reaches its maximum height. Now, does it want to know what that height is?
Yeah, it says that for question B. How high is the highest point?
Okay. So how do we get that? In other words, we just figured out where it's going to come on the horizontal axis. It's going to come at t equals 15/16 seconds. But what is the height going to actually be?
Don't you have to plug it in?
Yeah, this is the height, is y. So if I plug in 15/16 for t, I'll get the height. That's why we had such an odd number. Oop. And now we just have some arithmetic to do. This number here, I know, is minus 15 over 16, minus 15 squared over 16. And that is minus 225. That's what 15 squared is. See how I ended up with 16 in the denominator?
Yeah.
Because it's 15 squared times 16 times 16. In other words, what I really was looking at there was minus 16 times 15 times 15 times 15 times 16. Okay, this 16 cancels with one of the 16s, and I'm left with minus 225 15 squared over 16.
Okay.
Okay, so that's how I got that. That's minus 225 over 16, and then plus 450 over 16 plus 4. Well, this plus this is 225 over 16 plus 4. So that's the answer. Whatever 225 divided by 16. That's like, what is it? You have a calculator?
Yeah. It's 18.0625.
So 22, did you add 4 to it? already?
Yeah.
Okay. So what was it, 18?
Yeah, 18.0625.
There's your height. When it's at a maximum, it is at 18 feet above the ground.
Okay.
Now, they must have given you this equation. They're not going to expect you to memorize this equation, I don't think.
I don't think so either.
Okay. 'Cause that's a physics equation there.
Oh, really?
Well, it comes from physics, yeah, because the height of anything thrown up in the air is a function of gravity and the speed that you throw it up in the air with.
Okay.
Gravity comes from that because gravity is 32 feet per second in a downward direction. That's how you end up with the minus 16. You get the 30 from the speed. The initial speed is 30 feet per second. And you get the 4 from the initial height. He's 4 foot tall.
Uh-huh. Okay.
All right. What a week. So you scheduled another session Monday?
Yeah, I think I scheduled one Tuesday, too.
Okay, that's fine. Yeah, it looks like next week's going to be another chaotic week, at least the first 2 days, huh?
I bet, because the finals.
These finals must be on Wednesday. Look at my schedule. I got Monday and Tuesday, and then Wednesday, nothing. This kid here was on Tuesday, and I talked him into moving to Wednesday because he doesn't have a final on Wednesday.
Oh, my gosh.
No. That's the way it is every year, though. This is always the busiest time of year for me.
I bet.
I will talk to you next time, Ellen.
Wait, I have a really quick question.
Okay.
It says, for number C, it says, when is the ball at a height of 10 feet? I would just plug 10 in for H.
And solve that quadratic.
Okay. Just making sure.
Uh-huh. And if it says,
okay, thank you.
says, when does the ball hit the ground? Then plug in 0 for H. Because that's what the height of the ball is going to be when it hits the ground, is 0.
Okay.
And that'll give you the time that it hits the ground.
Okay.
Okay? Yeah.
Yep. Thank you.
Good night. Bye-bye.